Hello, everybody. Today's a very exciting day. We have something new and exciting and different happening today, and we'll probably horribly break. But if it works, well, if it works, it's going to be amazing. Hi, how you doing? Thanks for joining me here today. Uh, you are in the Intro to Kubernetes and Rancher course. Hopefully, that's where you meant to be. If that's not where you meant to be, well, hang out anyway, because you learn how to do some really cool stuff. I have made some changes today to allow you to actually participate more in the class. And you'll see those things in just a minute. I don't know where I was going to go with that. The other change that I've made is that this is now 2 hours long. It used to be 90 minutes long, and I never, ever, ever had enough time. There's just too much stuff to do. So, yeah, let's get started, right? That's me. I don't know what side I'm on that side maybe. My name is Adrian Goins. I am the Director of Community and Evangelism here at Rancher Labs, and there's all sorts of ways that you can contact me, but at this point in the training, none of those matter. I have not yet proven to you that I am somebody you might want to actually have a connection with, so ignore all of that. If you are somebody who likes to tweet about things and you want to tweet that, hey, I'm in a course with Adrian, please use the hashtags Rancher Training and Rancher Kates, and that way people, I don't know, people will know. Somebody described Twitter yesterday as a place where he goes to yell into the wind. We have a lot of stuff for you today. I'm really excited. I literally was working up until a minute before the class trying to get some stuff built. So yeah, there's some intro and housekeeping stuff. Then we're going to kind of install K3s. This is all messed up. I didn't update the slides. We're going to talk about Kubernetes and Kustomize, and we're going to give you a crash course in everything you need to know about how to do amazing things with Kubernetes. If you have zero Kubernetes knowledge, you are in the right place. Then we're going to go and we're going to install Rancher. And somewhere between 3 and 4, something is going to break because this is a live demonstration with new and unproven technology, because that's how we roll. If we're lucky, it'll work. If it doesn't work, that's fine. We'll figure it out. We're going to run through how to do stuff with Rancher, which is going to be kind of a recap of the stuff we did with Kubernetes. And then it always says final Q&A, but it's just me. Hello, just me. Which means in the GoToWebinar who's he what's it thing that you have on the side of your screen or wherever it is on your screen, for me it's over there, there's a questions panel. And I see some people have already hopped up some questions in there. So we got Ian saying good evening. Hello, Ian. And Chip saying hi, hi. And Jefferson asking, oh, Ian. Ian has let on a secret. We'll talk about that secret at the end. No, there's no WifeBot in these. She's actually out in the garden. For those of you who don't know what WifeBot is my wife, and well, I'll tell you how you can meet her at the end of the show. Questions panel. As you see, people are using it. That's what I keep my eye on over there, and that's where you tell me things like, stuff's totally not working, or you don't have any audio, or I tripped a circuit breaker a little bit ago and everything shut down. So hopefully that doesn't happen again. Anyway, if you have questions, when you think of them, post them over there and I'll pause periodically and go through and review them. Because it's only me, the only thing that I ask is that you keep your questions relevant to the information that you're learning today. So if you have specific debugging things about a Rancher deployment somewhere, well, there's other places where you can get help with that. All you need to know today is, well, there's other places. I'll tell you where those places are in a second. That was supposed to be a segue to the next slide, but clearly this slide has nothing to do with where you can get help. Today, you just need to know enough about containers that you kind of know what containers are. You probably should know what Kubernetes is, but if you don't know anything else, you're totally fine. This is what you want. And let me actually switch the news crawler there so that if you don't get this down right away, that's okay. There is a repo for today's class. And ordinarily there's a README there that I cut and paste from and I actually follow everything. I'm totally not using it today. Well, I'm kind of not using it today. Actually, that's not true. I will be using it today, except for the first part where we install K3s. But anyway, if you want to follow along, today is the day to do it. Today, we're going to actually have you install a Kubernetes environment, install a second Kubernetes environment, install Rancher into one of those Kubernetes environments, connect that Kubernetes environment back. So literally today's the hands-on day. Go check this out. or at least have it open in a browser so that you can follow along. This is going to scroll across the bottom of the screen, so I'm going to move to the next slide. Rancher has tremendous documentation. This is for those of you who are going to ask questions about the weird SSH error that you got with RKE. Go to the docs. Everything you need is in the docs. But if you're getting weird errors, we also have the Rancher user Slack, which is at slack.rancher.io. Well, it's actually not there, but if you go there, you can get an invitation, and then it's at whatever the actual URL is. There's also the Rancher forums. Slack is really the place to go. There are more than 20,000 people registered. There are thousands of people online at any given moment in the day. There's a dedicated channel for the Rancher Academy, which we'll talk about near the end. There's channels for K3S. There's a general channel. Go there and ask your question. And you might have to ask your question a few times. People tend to respond to questions when you ask them and also give some information that helps us identify the nature of the problem. If you just show up and say, I got an error with a host, nobody's going to answer you. So make it easier for people to help you by saying, here's what I did, here's the documentation page I was following, here's the error message that I got, what did I do wrong? Start with the assumption that you're working with a product that has over 30,000 deployments that we know about. It's the most popular open source Kubernetes management platform that there is, so it probably works. So whatever problem you're experiencing that seems like it doesn't work, not to be rude, but it's probably on your side of the keyboard, and that's totally fine. It's a complex, complicated piece of technology, and it's really easy to make mistakes. So don't be afraid to ask questions. Just come, ask questions. People will be happy to help you. I'm going to drop my camera off, and I'm going to kill the news crawler for a second, just so that we can focus on this, just for a minute. We get people in this session who don't actually know what Rancher is. So I want to just take a couple minutes and explain more than what I just explained. And it starts with two key pillars of a successful Kubernetes strategy. Pillar number one is a certified Kubernetes distribution, and pillar number two is centralized management. Now, of course, we have solutions for these things, but you don't have to use our solutions. As long as you're using a certified Kubernetes distribution and a management platform that does the heavy lifting of making it easier to work with Kubernetes, you'll be successful. Of course, I want you to use Rancher, but that's not why I'm here. But I'll still tell you about it anyway. Pillar number one, Rancher has two certified Kubernetes distributions, and that's certified by the Cloud Native Computing Foundation as upstream Kubernetes made easier for you. One of those is the Rancher Kubernetes engine, which runs all of the Kubernetes components inside of Docker containers. This is targeted for the data center. You need some beefier nodes to run it. I mean, not super beefy, but you can't like run it on a Raspberry Pi, for example. For that, you want to use K3S. K3S is our super lightweight Kubernetes distribution. It clocks in at around 50 or 60 megabytes. It runs all of the Kubernetes components in less than 512 megabytes of RAM. And this makes it perfectly suited for resource-constrained environments like IoT and the edge, but it also works just as well in a data center. It's the Kubernetes distribution that everybody's running. It just got accepted into the CNCF as a sandbox project, so it's not even ours anymore. It's the community's. It's just as much yours as it is anyone else's. And that's what we're going to be using today. We also have first-class support for hosted Kubernetes solutions. Those are more expensive, but if you're just starting out and you don't want to be in the business of managing the Kubernetes control plane, then, well, those are totally fine to work with as well. Once you have a Kubernetes layer, then you need something on top of it that's going to make it easier to work with. You can spend all your day bogged down in the nuts and bolts and the how Kubernetes works and stuff, but really why you're here is you want to leverage the power of Kubernetes to do whatever it is that you want to do in the world. So your management layer needs to hit on some key points. Consistent cluster operations. Rancher provides simple, consistent cluster operations that include provisioning, version management, visibility and diagnostics, monitoring and alerting, and centralized audit. Next, you need a security layer. This enables you to protect and secure and manage all of your clusters from a central location. This eliminates human error. Rancher provides that by giving you user access and security policies for all of your clusters, no matter where they're running. And then you need shared tools and services, which we provide by giving you a rich ecosystem catalog of services for building, deploying, and scaling containerized applications that includes app packaging, CI/CD, logging, monitoring, and service mesh. Once you have those two layers established, then anything you put on top of that, any application, is going to be successful. Here we have Rio, which is one of our projects in development as an application deployment engine for Kubernetes. But again, you can do anything you want as long as you hit certified Kubernetes distribution, management layer, and then application deployment. That's the end of my sales pitch. Did you like it? See if I can get the next slide to go. Look, okay, great. Here we go, K3S. Super, super, super lightweight. I'm gonna turn my camera back on so you can see me. Super lightweight. Does this still say I'm Matthew Shear? Matthew actually owns the account that we're using. I'm gonna fix that because I am not Matthew Shear. Let's see, my name is, it's funny, I really don't like the GoToWebinar platform. I'm filling in a box with my name and an email, and there's a checkbox that says, remember my name and email, which I always check, yet every single time I log in, it says my name is Matthew Shear, even though I'm the only one who uses this account. Okay, so there you go. Now look, webcam says Adrian Goins. Let me actually get that back off the screen, and where are we? We're here, we're talking about K3S. K3S is different from non-production solutions like Minikube, Microkates, Kind, things that are designed specifically for developers. And I already told you the specs for it. The default way of installing K3S is from the host itself. You log into the host and then you perform an installation of K3S and it sets itself up for a whole environment. Then you go to the worker nodes and you join the cluster. If you want to do that from a central machine, from like your local workstation, you can use a tool called Ketchup from Alex Ellis. That's how we would normally do it because I normally am working on nodes here in my house. I live in Chile. But that's not how we're going to do it today. If you are interested in Ketchup, you can get that from ketchup.dev, and it's a great way to install stuff even locally on machines. We're going to use a thing called K3D. K3D runs multi-node K3S clusters inside of Docker. It's fantastic for development. And even though a moment ago I was poking fun at Minikube and Microkates and Kind, it's very similar to Kind. The difference is that it runs K3S. So if you're running K3S out in production, and you want to run K3S locally so that you can do development against the exact same type of infrastructure that you'll be using out in prod. And for today, it's going to make it super easy to learn Kubernetes. Okay, now we get to the part that is probably going to break. Are you ready? I'm ready. Let me open up my little README over here. And while I'm doing this, open up a browser tab and go to that top URL, labs.playwithkates.com. Just go there. It's going to require that you, if you haven't been there before, that you log in with your Docker Hub account. So hopefully you have one of those. If not, very quickly go and make one, come back and log in, and then we'll be there. The other one that I need is docs labs.md. Okay, so I'm opening up a couple of documents here so I can have them in the background to refer to. If you are there and you're logged in, this is what you're going to see. This is an environment generously paid for by Docker and somebody else that I don't know. It allows you to run virtual machines that you can use for deploying and playing with Kubernetes. All of the instances that you create will be destroyed in 4 hours. Destroyed. It's very dramatic, right? Now, the first problem that you're going to encounter is when you log in and you click add a new instance, that's what you should see. It should just go blam, and there you are. If that doesn't happen, it means that you landed on one of the nodes that has a problem. I identified several nodes today that are out of disk space, and you can't see that from inside of your virtual machine. If you're on, oh, that's really small. Well, that's just how it's going to be. You're going to be typing the same commands, and we're going to be actually operating out of the README, so it doesn't really matter that this is small. I don't think I can make it bigger, can I? Oh, I sort of can. That's interesting. Certainly made it uglier. Okay, if you land on a node and things are running slowly, things aren't installing, you're getting errors that are out of disk space, all you need to do is just click close session and then wait a second and click start again from the main screen, and you will land on a different node. When you get to a node where your instance starts instantly, no pun intended, stay there because you're on a good node. All right. Hey, Jose says hello from Dominican Republic. Ian, what's the play URL again? This is labs.play-with-kates.com. Oops, that's not what I want. I want browser. All right, Paul says screen font is good. Thank you. Good to know. I try to keep things bigger. I edit a lot of videos from Rancher, and I see people do just like screen shares, and they've got that 4K monitor with like the 8-point font, and you're like, what? I don't know what you're showing me. I try not to do that. If you've been to one of my live streams, you know that like that's a big deal for me. All right. I don't know where you guys are, and since this is all new, I want to make sure that that I move slowly through this. Hopefully now you have. Let me actually get this readme up here. GitHub.com/rancher/Kate's intro training. Yeah, Kate's-intro-training. That's where you want to go. In there is a folder called docs, which I just created. In there is a file called labs. We're going to launch an instance. We're going to do some basic prep on that instance to make it useful. Then we're going to install K3D. Then we're going to launch a K3D cluster. That's called the working cluster. And then I'm going to show you how to talk to it and how to use it and how to do stuff with it. Then we're going to come back and we're going to launch a second cluster for installing Rancher. So if you're following along and you get to the launch the Rancher cluster part, you know, you can try to go ahead for extra credit, but if you break it, I'm not going to help you until we get to that part. For now, come up here to launching an instance. Click add new instance, and you're going to get an instance called node 1. Sorry that like my text is slightly scrolled off the bottom of the screen there. I wonder if I can fix that a little bit. Okay, like that. All right. The first thing you need to do is you need to install curl and which. So that's yum install -y curl and which. I don't know why these aren't installed, but without them, you're not going to be able to continue. This will do its thing. It'll take just a moment. And remember, if you have questions, if you get stuck, okay. So Bhargava, you're saying you're clicking on create, but not getting one. You landed on a bad node. Close your session, log back in, and eventually you'll get on a good node. I don't know what the problem is out there. Some of them, they're just having problems today. Oh, look at that. No space left on device. Even I landed on a bad node. This is totally outside of my control. When this works, I spent the last couple hours actually making it or testing it, so I know that it does work. So I'm going to jump out. I'm going to jump back in. I'm going to say add new instance. And nothing happens. I don't know, maybe there's like 10 nodes and 9 of them are bad and the rest of the planet is all trying to use the new one, the last good one. I should have just stayed on the one that I had. I didn't realize that they were having issues. All right, so let's close that again. Let's actually reload. I don't know if that matters. Let's say start and add new instance. Okay, I got an instance. Yum install -y curl and which. After this class, I will try to figure out who's responsible for this and go and let them know that most of their instances are busted. Okay, that worked. I'm on a good node. Hopefully you can find your way to a good node. And if you fall a little bit behind, that's okay. Just, you know, everything's in that labs doc, so you'll be able to catch up. Next, we need to install K3D. And this is done by one of those ever so heinous curl pipe bash scripts. But I work here and I promise that, well, it's not even your node, so what do you care? Okay, K3D has been installed. That was really easy. We're going to do some work on this node in a moment that uses a tool called Kustomize. And I know that you don't know what that is yet, and that's okay. I just need you to install it. So the next thing is another one of those horrible curl pipe bash scripts, which will install Kustomize for us, but it drops it into the local directory, which is totally useless. So the next thing you need to do is move Kustomize to user local bin. And if you already have a Kubernetes cluster out there, or if you are on a Linux machine, you actually don't need to do this. You can do this stuff on your local Linux machine and you'll be totally fine as well. Probably more or less. Because I've written the instructions for this environment. So if you have your own Linux machine, if you use Linux as a desktop, you're probably able to figure out what needs to change. But whatever, we're here. So now we have Kustomize installed. The last thing that we need to install is Helm 3. Again, I know you don't know what that is, and that's okay. This also uses a horrible verify checksum false bash script, and that's just because these machines don't have OpenSSL installed, and I didn't feel like telling you to install that as well. So if you're at this point, you have a node that has K3D installed, that has Kustomize and Helm. The next step, hey, Bhargava got a good node. Success. Chip says he also had to clear some cookies. Okay, cool. Failed wrong body. Failed to install K3D. Wrong GitHub Rancher K3D /main. Paul, that looks like you're out of disk space. Bounce to a different node. Failed writing body is these things like yum failures and stuff like like I said, I don't know what's going on. Can we paste inside the terminal on our node? I can. I have no problem pasting. As you've seen, I just copy and paste. Works fine. I'm using Firefox. Should work. That was a question from AJ. Swapneil says, please go slow. Share the page to copy the commands. Yeah, totally. The page to copy the commands is, hang on, let me jump back to the slides. Okay, so if you go to github.com/rancher/Kate's, is it Kate's intro training or is it's Kate's intro training, right? Browser. Yes, Kate's intro training /docs/labs.md. It's the only file that's in that docs folder, and that has the instructions. Lots of people asking for the URL. AJ can't paste. Jefferson asks, does piping to sh or bash mean to install it in user bin? No, it just means basically what you're pulling down is a shell script and you're piping it to bash and it's going to execute whatever is in the shell script. And the reason that people say, oh, don't do that, it's bad, is because technically you could be downloading a script that's like, destroy my machine, and you just did that. However, consider where you're getting the information from. You're pulling an install script from Helm, from Kustomize, from Rancher. It's probably okay. The alternative is you can just pull the script down, open it up, look at it, make sure that it's not going to destroy your system, and then execute it, change it to executable and run it yourself. It's just extra steps. And honestly, nobody does that. Okay. Hopefully at this point, everybody is at the place where they have a node, K3D, and some other stuff. And now we want to launch a K3D cluster. So that's this command here. What this is going to do is it's going to create a cluster, and you need to change name to something. Don't use the braces either. So I'm just going to call mine A because who cares? You're never going to use the name. It's possible to run. So the idea behind K3D is if you have a local machine, you can run multiple K3D clusters and you can start and stop them. So you can have them for different projects or whatever that you're working on. We're only going to launch one on each of the nodes that we're going to create. So it doesn't matter what you call it. We're then going to forward port 80 to port 80 on a node inside of the K3S cluster that we're creating called load balancer. You'll understand why you need that when we get to the Kubernetes part. I had a choice. I could either show you Kubernetes without you having the ability to run the commands, or we could overwhelm you with installing Kubernetes first, but at least then you'll be able to follow along with the rest of the stuff. K3D launches at a minimum one master node and one load balancer node. The load balancer node acts as a load balancer for every other node that's inside. You could have 6 nodes inside, master and a bunch of workers, and traffic that lands on the load balancer node will get directed to all of them. Because K3D launches Kubernetes inside of Docker, all of those nodes have a Docker IP, which is different from the host IP. We need to forward ports from the host IP to the node IP, or sorry, the host IP to the node IP inside of the cluster, and that's what we're doing here. We're forwarding 80, and we're forwarding 443, and then we're also forwarding the Kubernetes API port so that we can actually talk to these nodes, this cluster, from outside if we wanted to. I don't know if we need to, but I threw that in anyway. So copy this. Actually, I'm just going to copy from here over because I know the first part. Come back over to your playground, and I'm going to say K3D cluster create. I'm going to name mine A, and I'm going to paste all of that. Ah, AJ, are you on a Mac? Check here in this little thingy. Oh, well, I only have Mac OS shortcuts. I thought maybe, so I use Command V to paste because I'm on a Mac. Maybe there's a different something that you need. This is totally useless, so forget it. Okay, K3D cluster create. The name of the cluster, mine is called A. Forwarding ports 80 and 443, and then we're also saying the API port. What? No space left on device. Oh my gosh, are you kidding me? What a useless service. All right, I'm going to create another node. Okay, after this class, everybody needs to write to Docker and just write a big email that just in like big letters just says WTF. All right, I have node 2. Let's try this again. If you create a new node, and this is why I made it so you can actually copy and paste all of that stuff from the other one. No space left on device. Oh, we're already half an hour in. That's exciting. Well, if this doesn't work, then I will fall back to the way that I was previously showing you guys how to do stuff, and it did not include a, hey, follow along with me in real time option. So I just copied and pasted that whole thing, which allows me to very quickly get back to where we were, and hopefully can I K3D cluster create. My cluster's name is A. There's my ports. Maybe the Kubernetes gods smile upon me, perhaps. What do you think? Think people are running like crypto mining software or something on these? Probably. Okay, I got a Kubernetes cluster. Did you get a Kubernetes cluster? AJ wants to know what customize is. We'll talk about that in a second. Swapnil says, getting error. You're not pasting your error, so I don't know what it is. AJ says, works on IE. Okay, you're on Windows. Okay, there you go. Ian says, yeah, wait for the usage and storage bill to be returned. Yeah. All right. We need to move on. So hopefully you can get to where you have a cluster. If not, I'm sorry, but you'll be able to come back to this later and you can try it on your own Linux machine or something. Let's start teaching. Kubernetes is feared across the land for its complexity and its difficulty, and that's total garbage. Kubernetes is as complicated as you want it to be, but it's really made up of simple blocks that you assemble into an application. When you are approaching any problem in your world, you have two choices. You can tell yourself that the problem is easy, or you can tell yourself that the problem is hard. Your brain will believe both of them. So if you tell yourself that it's hard, all you're doing is making it harder for you to learn. Everything new is a challenge. Think about anything that you're able to do today, whether it's drive a car, fly an airplane, use a computer, walk. Those things were impossible when you started doing them and you thought, I'll never be able to do this. But now you get into a car, you start it, you drive away, and hopefully you don't, in God's name, really? Skype? No. I have a Skype phone number. I live in Chile, but I have a Skype number for the US. And the only thing I get on it are calls from, congratulations, you have been selected to win a. And I've tried using every single anti-spam, don't allow people to call me thing inside of Skype, and I still get those calls. Anyway, sorry, that was my stupid Skype phone ringing. Where was I? Ah, yes. So you can decide how you want to proceed with these things. I'm here to tell you that things are a challenge, but all challenges can be overcome. And if you have zero experience with Kubernetes today, you're going to end this class knowing how to build and deploy a simple Kubernetes application using these things: pods, replica sets, deployments, config maps, services, and ingresses. With those 6 things, 2 of which you don't even really need to care about, you can do a lot. Once you have those core tenets, you will be able to add on knowledge as it's relevant. And that's how the brain retains knowledge. It makes an association between information and the relevance of that information. So you could learn a whole bunch of stuff and forget it immediately. But as soon as you say, oh, I need this to solve this problem, your brain's like, oh, okay, that's important. Let me save that data. A pod is the smallest unit of anything that you can deploy in a Kubernetes cluster. It's one or more containers that are scheduled together on a host. They share storage, they share networking. A pod has a unique IP address, and that enables containers inside of the pod to talk to each other on localhost. A pod is not a real thing. It's a logical representation of a group of containers. Here's an example of a pod. You have 2 containers inside. There's a file puller container that retrieves content from some external CMS and it saves it to a disk. Then there's a web server container that responds to requests from consumers and it retrieves content from the disk and delivers it. Together, these make up a function of an application. And we can get into like microservices and stuff, but we're not going to. Just understand that when your application needs more horsepower, you're going to scale up the number of pods for that component. They're called replicas. So when we need more web servers because we've got an influx of traffic because our content's really popular, we're going to go from 1 to 2 to 5 to 10 to 1,000 or whatever pods. You wouldn't, for example, have a web server and a database server because when you need more web servers, you don't need more database servers, and those wouldn't be able to talk to each other or really do anything anyway. It's a great example of what not to do. Everything in Kubernetes uses what's called a manifest, and manifests are written in YAML. But don't be afraid. You're not going to actually write YAML. There are tools and things and ways to generate YAML for you, but ultimately what you end up with is some YAML, and the YAML gets applied to a cluster. All YAML, all manifests, not all YAML, all manifests have 4 top-level keys: API version, kind, metadata, and spec. API version tells Kubernetes where in its API it can find information about how to create the thing that you're asking it to create. In this case, that's a pod. There are many API paths. Pod is a simple object that's been there from the beginning, so it's in the V1 path, which is stable. But things start out in alpha, they move to beta, eventually they move to stable. Vendors have their own vendor-specific paths. So it just says, where do I find this thing, and then what am I making? Metadata we'll talk about in a sec. Well, in a minute. Spec is the information about the thing that you're creating. In our case, we are creating a pod. A pod has one or more containers. So there's a containers key followed by a list that contains information about the containers. A container at a bare minimum needs a name and an image. In our case, we're also overriding the image. Sorry, we're overriding a command in the image to tell it to do something else. If we come over to our, so used to pressing terminal, but that's not actually what I want. If we come over here, back to where we have our cluster, it retrieved a file called a kubeconfig. It saved it for us in ~/.kube, and the file is called config. This is the default location where a command called kubectl, kubecontrol, kubectl, kube, whatever you want to call it, looks for information about clusters that it should talk to. We type kubectl get nodes, you see that we have one node, K3D A server 0, and it is a master, and it's been up for 6 minutes. Forgot to tell you to check out the repo that we are using. So that's github.com, Rancher, Kate's intro training. Whoops, not get. Man, why doesn't the computer know what I get clone? What? Why doesn't it? Why can't I think? Oh, that totally didn't work. Not get checkout. So this is the problem with talking and typing. Get clone. Okay, so clone that repo. That's the same repo that we had up before, where you've got it open with the labs file and you've been copying and pasting out of it. Not a big deal. If we cd into there, there's a file called pod.yaml, and you can see it's the manifest that I was just showing you a minute ago. We apply manifests to the cluster with kubectl apply. Then you tell it what file you want to apply. In this case, pod/pod.yaml. We're going to apply this to the cluster. It's going to create a pod. That pod is going to do something, and then it's going to exit. And I want you to think to yourself, what's going to happen when it exits? Once something has been applied to the cluster, you can look at the pods with kubectl get pods, or you can look at anything else with kubectl get the thing. This shows you the state. If you wish to have it continuously observe the state, you can pass -w, and it will report any state change. And you see with the status there. So the pod ran, it exited, Kubernetes restarted it, it exited, Kubernetes restarted it, it exited, and Kubernetes said, okay, hang on a second. Unless you tell me that the thing you're telling me to do is going to run and then exit, my job is to make sure that it stays running. So every time it exits, I'm going to restart it. But clearly, there's something wrong here because it just keeps exiting. So I'm going to back off. I'm going to give it a few seconds to think about its life and the life decisions that it's made. And I'll start it again. Oh, you exited again. All right, clearly you need more time. I'm going to give you even more time. That's a crash loop back off. Starting things that are exiting is very expensive on the system, and Kubernetes' first job is to protect the system. So it increases a timer before restarting. 1 second, 2, 4, 8, 16, 32, up to 10 minutes between restarts, hoping that whatever the thing is will either figure out what its problem is, it needs a cache, it needs a database, something, I don't know, or a human will come along and be like, whoa, that's totally not working, let's fix that. With me so far? Bhargava is asking to explain pod YAML again. Unfortunately, no. Sort of, quickly. API version, kind, metadata, and spec, 4 top-level keys. API version, where do I find the information about the thing that you're telling me to create? In this case, that's a pod. Metadata, we covered in a bit. Spec is different for each of the things. In this case, a pod spec has a key for containers, and there's a list under there of 1 or more containers. We're going to spend a lot of time in YAML over the rest of the slightly less than 90 minutes that we have left. So you'll get a lot of this. Now we have a busted pod. Let's get rid of that. kubectl delete pod. Actually, hang on. kubectl get pods, because I don't remember what its name is. There we go. kubectl. There's lots of ways that you can do stuff in Kubernetes, and throughout the course today, I will show you several different ways to do stuff. So one is we could say kubectl delete pod myapp dash pod. That would work. But we launched our pod from a manifest. So we can also say delete and then point to the same file that we used to launch it. That also works. There's no way that's right versus another. It's just whatever you feel like doing, whatever your fingers like typing. Oh, sometimes I forget to bring water to the class. Rancher water bottle. Limited edition. All right, so that's a pod. The thing is, you're basically never going to create a pod because by themselves, they're useful, but you don't have a good way to interact with them. But before I talk about what you are going to do, let's talk about declarative and repeatable actions. If this is your first introduction to Kubernetes, this is going to be a mouthful or a brainful. But if you've worked with any type of configuration management system, Terraform, Ansible, Puppet, Chef, anything like that, you understand the value of having a system that can do a thing. The reason that we want that for infrastructure as code or config management or whatever you're using it for is because I could make a change. I could close my laptop. I could go on vacation. I could be on a sailboat in the middle of the ocean scuba diving, and the cluster could crash or the systems could crash. And my colleagues have no idea. They have no idea what the last thing was that I did. So they don't know how to fix it. They might think that they know, but then it might not come back to the same state. All of that is just terrible. I don't want them to call me. I'm not kidding. I used to own a company that built and managed data centers for other companies, and I would go on vacation on sailboats in the ocean, scuba diving, and I would take a satellite phone with me just in case something broke. And at the time, I thought I was super cool. And now I look back and I'm like, wow, that was really dumb. Who wants to be on a satellite phone for like $2 a minute trying to fix a busted machine 4,000 miles away? So just don't be like me. There was no real good way to do this with Kubernetes until some people created a tool called Kustomize. Kustomize allows you to template out your manifests and put them in a Git repository. This leads to a new workflow management concept called GitOps, where Git becomes the source of truth, the repo itself, and you never make changes directly on the cluster. You change a manifest, you apply it to, you commit it to the repo. It goes through some CI/CD testing process for validation and whatnot, and only after it passes those tests does it get applied to the cluster. Now I'm on a sailboat in the middle of the ocean, swimming with whales or doing whatever it is, and the cluster crashes, and the people who work with me are like, oh, that's no problem. Let's just fire up a new cluster, deploy all the manifests from Git, and we're right back where we were. So while this is a lot for your first day, I'm going to show you just a taste of how you can do this so that as you continue to learn and grow and develop, you know what's available for you. Whenever I used to buy books, remember books? Books back in the day, they were these things made of paper. They looked like this. They had pages with words on them. Right? These are like relics now. Now this is a book. This horrible, really expensive. I can't even open it. This thing, people think that's a book. Just no. I used to go to bookstores and I'd buy the big thick books on whatever Apache server or something like that. And you look at the table of contents and you look at the index. And if the index is written in really big font, the book sucks. If the index is written in really tiny font, but it has index references for things like the and cow and like really simple words, the book sucks. But if the table of contents has good topics and the index is small print, relatively long, about meaty topics as well, then the book is really good. But nobody's going to read a book that's this thick. And well, you could, but you're not going to remember it. So instead, read the table of contents, read the index, pick apart the things that you're interested in, and now you know what it's capable of. And later, when you encounter a problem, your brain's like, oh, I saw that in the index. And you go and you learn that piece. And then you have another problem or you have a new thing you want to learn. That's the association thing I talked about earlier. So that's my objective for today. Show you lots of ways so that as you move forward, you have lots of ideas and lots of awareness and lots of whatever. Let's move. Kustomize was baked into kube control back in 1.14. You can get information about it from kustomize.io, and that's all we're going to say about that. Now, I told you you're not going to create pods. Well, okay, so I lied. You are going to create pods, but you're not going to create pods directly. You're going to create something else that then creates the pods. And the reason you want that is you want Kubernetes to have a thing that's babysitting the pods, because they might get deleted, they might crash, something like that. You need Kubernetes to maintain state. State in today's class has two meanings. There's stateful and stateless applications. We'll talk about those shortly. And then there's the desired state and the actual state. And that's what Kubernetes ultimately does. Kubernetes understands the desired state and the actual state. And if they're not the same, it does whatever it needs to do to make the actual state reconcile with the desired state. So here we have 3 nodes. 12, I know I'm talking really fast. It's because we lost time trying to get these things all set up. So I'm sorry if I'm talking fast for a lot of you. I do keep checking the questions panel. Juan says I missed everything. That's funny. Well, I'll throw this news crawler back up. Yes, there will be a recording. You can come back and you can play it on YouTube at 0.5 speed. And okay. Hey, Juan is an Academy graduate. That's cool. Oh, do I have the bad docs in there? Okay. Paul, you're ahead of the class, but thank you for telling me that that doesn't work. When we get there, I'll give you the right way to do that. Hang on, I'm actually just gonna fix that right now. Helm install. Remember I was doing this up to like a minute before the class. Manager. Helm install. Yeah, totally right. This is the way that we had to do it with Helm 2. We don't do it this way anymore. We do this. Let me just commit that. Install yep. Docs. Okay, I just pushed that out to Git. If you give it a few seconds and refresh, you'll see that command update. Thank you for telling me that was broken. All right, cool. So back to this. Here you've got 3 nodes, 12 replicas. One of the nodes dies. Well, Kubernetes recognizes that the desired state is 12. The actual state is 8. So it launches 4 more. And that's really all that it does. The thing that's responsible for babysitting pods is called a replica set, but you're not going to create those either. You just need to know what they are. What you're actually going to create and where you're going to spend most of your time with Kubernetes is with a thing called a deployment. I'm really glad we have extra time for this class today because we're definitely going to need it. A deployment is a level of abstraction above a replica set, and it gives a much better interface for interacting with pods themselves, particularly around a thing called a rolling up. It says upgrade, but that's a lie. A rolling update. Imagine that you have an application deployed. It's version 1.0. Version 1.1 comes out. So you tell Kubernetes, hey, I'd like version 1.1. You never tell Kubernetes how to do stuff. You tell it what you would like the desired state to be. You express your will. You can give it parameters about how it can make decisions, but ultimately Kubernetes is going to make the decision about where to put things and what it needs to do to reconcile state. So version 1.1 comes out. You express your will. I would like 1.1. And it says, okay. And that's how Kubernetes always sounds. Okay. It's like the guys from World of Warcraft or Warcraft, whatever. Job's done. It's going to start out by rolling out new versions of the application in new pods, and then it's going to kill off old ones, and then it's going to roll out new ones, and it's going to kill off old ones until you now have the desired state and the actual state of 1.1. If this fails for some reason, you can do a roll back and, well, and yeah, so you can roll stuff back. What does this actually look like? If you go into the deployment base directory, inside of there are some files. This is your first introduction to Kustomize. Take a look at the customization.yaml file. And also, if you're not following along with an actual Kubernetes cluster for whatever reason, all of these files are in the repo. You can just have a browser open and go and look at them. You just don't get to deploy them. Sorry. All right. This is not complicated. Basically, what it says is there are some files in this directory, deployment.yaml and service.yaml. Just deploy those. And then create a config map. You don't know what that is. That's okay. Create a config map with the name index, the contents of which come from this file here. If we look at that file, it's just a simple HTML page. And when I get to the config maps section, I'll explain to you what that is and how it does, what that is and what it does. So if we look at the deployment.yaml, you'll see that it's a little bit more complicated, but it still has our same thing. So API version, it's in a different API path. Kind is a deployment, metadata, and spec. Now, spec is a little bit different because ultimately a deployment is responsible for creating pods. It creates replica sets that create pods, but ultimately you can just think that deployment creates pods and you can just ignore that thing that happens in the middle. So we say, how many pods do we want? We want one. Down here under template, you'll see that it looks very much like the pod spec from before, and that's because it is. It has metadata and a spec, containers, and then the list of container information. And there's more stuff in there, but don't worry about it. Here, though, I want to introduce you to metadata. Metadata is metadata. Metadata is just extra information around a thing. And in most cases, it's arbitrary. You have two types of metadata that we'll work with. One is a label and one is an annotation. We don't do annotations today, but just know that they exist because you're going to see them. Labels are arbitrary key value pairs that allow you to identify uniquely an application. So in this case, you see we have a label of app is Nginx. These are arbitrary. Environment, production, business unit, finance, whatever. But the combination of labels should allow you and Kubernetes to uniquely identify what something belongs to, because that is used up here with the selector. So the deployment has a selector that says, I will care about any pod that has the label of app is Nginx, whether I created it or not. Conveniently, the pod will be created with a label of app equals Nginx. Selectors are pretty much how everything in Kubernetes finds stuff, because you can't find by IP because stuff will get deleted and recreated. You can't find things by uniquely because they'll get scaled up and scaled down. So things self-register in a group by labels. And you can select on multiple labels. So you can select on the and of label and or of a app and environment, or environment and business unit, or whatever. You could say the app equals Nginx and environment equals production or staging, whatever, totally arbitrary. But that's where metadata is used. Up above in the deployment itself, there's also metadata, but nothing is using this for selecting anything. It's just good practice to label your stuff so that all your application components show up together. At a bare minimum, under metadata, everything needs to have a name. Because if you don't have a name, well, then who are you? This also creates a service. We don't talk about services yet. I'm just saying it creates it. When you are applying stuff with Kustomize, you use kubectl apply -k, and you point it at a directory that has a customization file in it. That, you see, created the config map, the service, and the deployment. All in one, done. Let's go home. No. You can do things like I could change the deployment and I could change replicas to 3. And now if I rerun kubectl apply -k, well, imagine that I made that change and I committed it to a repo. And now something else is doing the application to the cluster. You see that it recognizes that the config map didn't change and the service didn't change, but the deployment did. And so it updated the deployment. If I run kubectl get deploy, you could type get deployment, but you're just wasting characters. You see that we have an Nginx deployment, and it has 3 out of 3 pods ready, 3 are up to date, 3 are available. If I say kubectl get replica set, you see that we have a replica set that is linked to the name of the deployment. And if I say kubectl get pods, you'll see that we have 3 pods, and they are named such that you can figure out what replica set they belong to and then back up to the deployment itself. So what can we do with this? Wow, it's already 3 o'clock. Next week, the class will be 3 hours long. Just a real quick check questions. All right, no more questions. That's good. That means that you guys are following along, I hope. No, that's not the window that I want. I want this one. What can we do with this? We can, well, we can scale it. So let's actually scale that back down. Let's edit that and let's go. Let's just change that back to 1. Let's apply that again. And let's get our pods, and you'll see that, instantly, 2 of them terminated. We're back down to 1. Remember I told you that there's lots of ways you can do stuff in Kubernetes? Well, you can scale a deployment manually by saying kubectl scale, deploy nginx, and then pass it the number of replicas that you want to scale it to. And now, boom, there you go. You got 3 replicas. You can scale it up to 5. And there you go, container creating. But let's change the image. I should just copy and paste this since we're running out of time. Well, not running out of time, but time is valuable. All right, kubectl set image deploy nginx. We want to run nginx 1.17 alpine. I don't actually need that -- record in there. That's old. And so it's been updated. So this will begin a rolling update of the application. We can watch this happen by saying kubectl rollout status and then pass it the name of the deployment that we care about. And we could wait here for the rest of the class and this would never change because there's a problem. Well, how do you deal with problems? No, it's not pawns. kubectl get pods. Ooh, okay. Well, we have an error message. Let's pretend for a second that we don't know what that error means. I want to point out that we have 3 pods in an error state, but we still have 4 pods running from our previous application. So the site's up, customers are using it, boss isn't mad, we're not going to get fired. We've got the time to go and figure out what the problem is. We have been using kubectl get. And kubectl get is very powerful. You can say, for example, kubectl get pod, and then you can pass the name of a pod, and you can say -o YAML. And let's pipe that to less. This will actually reach out to the cluster, bring back the YAML for the particular resource, and then show it to you. It's got a lot of default configuration stuff in there. It's kind of noisy, but this allows you to see things that are running in the cluster. You can say, oh, well, how does that work? You can just go grab the YAML and look at it. There's nothing hidden from you. Well, not by default, certainly not if you're an admin. This is like looking at the skeleton of an object. This is what it is, what defines it. It's muscle tissue and skeleton, brain, and things like that. But you also sometimes need to see how Kubernetes sees an object from the outside. For that, we use a command called kubectl describe. And we'll say kubectl describe pod, and then we'll pass it the name of one of those pods that's in an error state. Pipe that to less as well. And now you see how Kubernetes sees it. So this is its definition, but you get interesting things like what's its status, what's its IP, what node is it on, what are its labels, when did it start, blah, blah, blah. And down at the bottom is a section called events. Whenever you're doing any kind of troubleshooting, you're going to go kubectl get pods, you're going to go kubectl describe on the thing that's being bad, and you're going to look at the events. Period. That's just how it works. Here, you have every single thing that happened since this thing was born. So it was assigned to a node, it tried to pull an image, it got an error, and there's the error message. Image not found. Because I misspelled alpine. It's terrible. Well, what do? kubectl rollout undo deploy nginx. Whoops. Deploy engine can't type. Deploy nginx. kubectl get pods, and we're right back to our 5 running replicas from before. Okay. Well, let me show you a different way that we could do this. And that's with kubectl edit. Just like kubectl get, when you said send me the output in YAML, kubectl edit will bring down the manifest and open it up in an editor for you. In this case, it opened it up in VI. That's good. I'm glad it didn't open it in Pico. We're going to search for image, and there it is. And let's just change that from 1.16 to 1.17. When we save and quit, that gets applied to the cluster. And now, if we look at kubectl rollout status, that is probably already done. Okay, so we caught the tail end of the rollout, and we see that they're available, they're rolled out. kubectl get pods, and we now are updated. Cool, right? Jefferson says there's another session next week. I do this class every other Thursday. So if you go to rancher.com/training, I think, or online, I think rancher.com/training. Yeah, rancher.com/training. And well, this is today's class. After today, this will update for the next one. The next one I'm actually not doing. I'll be on vacation that day because it's the day after my birthday. It's actually my anniversary with WifeBot. So that'll be Dawn High, but then I'll be back 2 weeks after that for the next one. You can also register for Kubernetes masterclasses. We have one coming up next week on Service Mesh and API Gateway. These are more advanced Kubernetes topics with partners and how to do some really cool stuff with Kubernetes. Okay. Hey, Eugene caught that the image name is misspelled. Extra credit for you. I intentionally try to make it like it's an accident. That's why I'm like, oh yeah, I'll copy and paste it. No, it's so I can simulate a failure and show you how to do the debugging. All right, next. Next. I've shown you a little bit about Kustomize. And at this point, you're probably thinking, this is just like more work than doing it regularly. And you're right. But let me show you why Kustomize is awesome. First of all, let's delete everything that we just built. Poof, gone. And let's come up to the overlay directory, inside of which there is a staging and a production directory. We'll go into the staging directory. And let's look at the customization.yaml file. In here, you see some additional things. For example, everything will be prefixed with the name staging dash. Everything will get a common label of environment is staging. It will start by using the base configuration from the directory that we were just in. Then it's going to patch it with stuff that's in this directory here, those 2 files. We'll look at them in a second. It's then going to replace the existing config map with config map data from this directory. If we look at that, you'll see that that just says hello from staging. The other one said hello from default. If we look at replica count, you'll see that it's going to patch it and say we only want 1 replica. And if you look at image, you'll see that the staging environment is going to run nginx 1.17. If we apply that, we get a staging environment. If we go up into production, it's very similar, except it's all built out for production. The image is going to be Nginx 1.16 because production is a little bit more conservative. And the replica count is going to be 3 because it's production. And the config map says hello from production. We'll apply that. And now if we say kubectl get pods, you see that we have a staging environment, a production environment. We have the 2 deployments. They're labeled, they're identifiable, and they all came from the same base directory. That's the real power of Kustomize. Kustomize allows you to build out your manifest and then just change only the things that you need to change for the specific environments where they need to be changed. This saves so much time and headache in people making mistakes. When you have to make a change in a manifest in like 17 different places, somebody eventually is going to screw it up. In fact, one of the things that I believe above, you have those things in your life that you just believe. One of the ones I believe is that any task that any human has to do repeatedly will eventually break, because we are terrible at doing the same thing the same way over and over and over again. We make mistakes, we try to optimize it, we try to make shortcuts. Have computers do that. Go scuba dive. That's kind of the end of what we talk about Kustomize, and actually the end about deployments. So let me just check the questions here really quick before we jump into, can you guys still hear me? Swapnil says he can't hear me. Swapnil, since you're the only one who says you can't hear me, I'm guessing that's GoToWebinar. Remember when I said GoToWebinar sucks? That's one of the things it does. It'll just stop sending audio. Disconnect and reconnect and you'll be fine. Yeah, everybody else says fine. So Swapnil, after you send that WTF email to Docker, send one to GoToWebinar. Next, config maps. If you've ever deployed, okay, well, look at what we just deployed. We deployed the Nginx container, and that has an nginx.conf file in it that's the configuration file. 100% of the time that you deploy that, that configuration file is not what you need it to be. Okay, 99.6%. If you deploy that in production, you're going to have to change it. And this is true of all sorts of container images. So what do? Do you roll your own container? So from Nginx, add my config file. Great, I've got my own container. I'll deploy that. Sure. But now you're in the business of maintaining a container image and keeping it synchronized with upstream. You don't want to do that. You could also set up an NFS server, for example, and mount a volume with the config file and all the containers. And no, Kubernetes, these are problems with Docker. Kubernetes solves these with config maps. A config map is just a file with key value pairs, and they override container-specific data in one of 3 ways. Environment variables, so it could be, in the config map, the key is the environment variable name, the value is the value of the variable, and those get mapped into the container at runtime. Or the key can be a file name, and the value can be the contents of the file, and those get written to a directory at runtime. Or you can have an entire directory taken over where every single key becomes a file in that directory. What is super duper duper amazing about config maps is that they are updated real time without you having to restart your pods, which is amazing. Your application is still responsible for detecting a change in a config file, for example, and reloading itself, but now you can make changes inside of containers and override files and change values and stuff like that, independent of the operation of the container and the pod. There are 2 schools of thought around this. One is that this is totally awesome. The other one is that this is totally not awesome. And both of them are right. In the totally awesome camp, we have people who say, I don't have to restart my stuff. I can just detect that something changed and I can reload my application and holy cow, this is amazing. Yes, except, well, yes, period, full stop. Let me tell you about the other school of thought. The other school of thought says, if somebody can change a config map and update the running state of a container, then we have deviated from the source of truth, which is the Git repository, if you're using GitOps. They're also correct. So there are 2 ways to handle this. One is just do what you're going to do anyway, and it just gets updated in memory, and that's fine. The other is if you use customize, then by default, it versions the names of your config maps. If I say kubectl get config map, you'll see that it's staging, index, and then some crazy thing. If we were to go in and change our, in fact, let's vi and production, right? Vi configs index. Hello, this is the production environment. Woot. And now if I say kubectl apply -k dot, it will update the config map. And now if I say kubectl get pods, you'll see that it's doing a rolling update of the production environment because it created a new config map. You see there are two prod index ones there. What we've just done, if you imagine that there's a Git repo involved, is we've made sure that the state of the thing in the repo accurately reflects the state of the thing in production. Which one you choose is entirely up to you and the level of, I don't even know what the word would be there. Whatever, it's up to you. Do whatever you think is right and you will be correct. It's just my job is to show you the different ways to do things. Moving on. So we have pods. We have an application running. Nobody can talk to it, which makes it totally useless, mostly useless. Services are a way to expose your application outside of the cluster, potentially. There are three types of services. First is a cluster IP service. That creates a stable DNS name and IP address only accessible from inside of the cluster. The thing about pods, as I keep saying, you can't trust them. Like they do what they're supposed to do, but the address that they have, that could belong to a different pod someday, or the pod could move to a different node. You don't know that the pod you're talking to today is the pod that's going to be there. Services you can trust. So cluster IP, stable DNS name and address only accessible from inside the cluster. If you have a web application and it needs to talk to Redis or Memcache or something like that, but you don't need to talk to that from outside, then cluster IP is fine. Node port service first creates a cluster IP service, then it opens up a high port on every node in the cluster, and traffic that lands on that port gets directed to the service, and that gets directed to the pods. You'll use this if you have an external load balancer that you can't control from within Kubernetes. So if you've got a NetScaler or a HA proxy system or something, you would configure HA proxy with all of the nodes in the cluster and that node port, and then it would actually receive traffic on port 80 or port 443, and it would forward it to the cluster backend. Easy, right? This is load balancing 101. If your Kubernetes cluster is in a place, well, in a cloud provider, usually, and it knows how to talk to the cloud provider, and it's got all of the magical bells and whistles that tell it how to talk to the cloud provider, and then when you create a load balancer service in Kubernetes, it first creates a cluster IP service, then it creates a node port service. It opens up that port on all of the nodes in the cluster. Then it reaches out to the cloud provider over their API, and it creates a cloud load balancer. In case of AWS, for example, that's an ELB or an NA, network load balancer. It then configures that load balancer with all of the nodes in the cluster and the ports and the so on and so forth, and it maintains that configuration for the life of the service. So if a new node gets added, it gets put in the node pool. If a node gets deleted, it gets deleted from the node pool. That's a load balancer service. If you're running in a on-prem or bare metal or private cloud environment, you can still do load balancer services using a tool called MetalLB or a new one called kubevip. These take a pool of addresses, and when you create a load balancer service, they assign an address to a node as an extra address, and they start ARPing or configuring that, injecting that into a BGP fabric. And that, well, then traffic lands on that address and all the magical who's what's it's happen. Checking questions here. Okay. Chip asks, is a replica set just the manifestation of a pod? No. Deployment creates a replica set. Let me jump back over here. So a deployment creates a replica set. And let's look at one of these. A replica set actually creates the pods. There's a thing called a replication controller that you can use to create replica sets directly. This was before deployments existed. It doesn't, nobody uses it. Replica sets are just kind of a holdover from a previous day. You can genuinely just forget that they exist and just think deployments create pods. But in truth, a deployment creates a replica set. And you see down here that it's what you saw in the deployment thing. The number of replicas that you want, the selector for the pods that it cares about, and then the template of what it's supposed to create. What are the pods themselves? Pods are pods, replica set is replica set, deployment's a deployment. They're different things. Jefferson wants to know, do you need to apply changes to the, oh my God, there's so many questions. Do you need to apply changes to the YAML? Does Kubernetes rollout update automatically, or do you need to apply it manually? Hang on, he rephrased that. When you apply changes to YAML, does Kubernetes rollout update automatically, or do I need to apply it manually? Cluster's over here, I'm over here. My YAML is over here. I edit the YAML locally. All I've done is I've changed a file over here in the terminal. I need to then apply that to the cluster. That's one way of doing it. Another way is I can say kubectl edit, at which point kubectl goes out to the cluster, brings back the YAML, and shows it to me inside of an editor. When I make the changes and I exit and save and exit, kubectl takes what I've just created and applies it back to the cluster. That's the difference between kubectl edit and then whatever the thing is versus editing the file locally and then saying kubectl apply my local environment to the cluster. Oh, Paul has a question about VirtualBox on Mac OS. Yeah, that's more complicated than I could talk about in the class. That's okay. Well, if you're running VirtualBox, set your network interface to bridged, not NAT. If you set it to bridged, it will get an IP address from your DHCP server in your network, and it will behave as a machine in parallel to your Mac, and you can just talk to it directly on its IP. If you do NAT, then it's internal and wackiness ensues. You got to do port forwarding and stuff like that. AJ wants me to quickly revisit load balancer service. Super quickly, just for you. We know cluster IP. We know node port. If your cluster, your Kubernetes cluster is in a cloud provider, it's in AWS, there's a bunch of extra configuration that you have to do so that it knows how to talk to AWS. Basically, the cluster knows, oh, I'm a cluster in AWS, and here's my credentials, and there's a bunch of stuff. If you've done all of those things, then when you create a load balancer service inside of Kubernetes, Kubernetes first creates a cluster IP service, opens up the node ports, that high port on all, I didn't tell you the port number. The node port is a high port between 30,000 and 32767. So it opens up a high port, and then it reaches out to Amazon's API and it creates an Amazon load balancer, an Elastic load balancer, a network load balancer, something. It then configures the load balancer with the information of all of the hosts and that high port that was created, and then it maintains that configuration. When the environment changes, it updates the load balancer. That's the default configuration for load balancer services. But if you're running in an on-premise environment, there are two applications that you can run. One is called MetalLB, the other is called kubevip. And the way that these work is you give them a pool of addresses from your local network, and when you create a load balancer service, I use MetalLB. MetalLB says, oh, a new load balancer service. It goes and grabs an address and it sticks it on one of the nodes. And then that node begins going, I have this address, I have this address, which is called ARPing. If you ever looked at network traffic, it's like ARP, who has, oh, blah, 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 and it's all layer 2 stuff. It can also do route injection into BGP. If you have a BGP fabric already, then you can have your Kubernetes cluster inject routes into BGP so that all of that stuff magic works. So that's MetalLB and kubevip for on-prem. The reason you can't use those in a cloud environment is because cloud providers generally don't let you just arbitrarily start announcing addresses off of your nodes. Okay, We still have a lot of ground to cover. Services are effectively layer 4 load balancers. I call them dumb load balancers. They just receive traffic on a port and they send it to something. We created a couple of those. kubectl get service. You see that we have here a staging nginx service and a prod nginx service. Both of them are listening on relatively high ports. Yeah, tea. Whitebutt brought me tea. Ian's in the chat. Whitebutt says hello. So you see that they're listening on high ports. So those 2 ports there between 30,000 and 32767. If I were to curl localhost on 3104, nope, wrong. Curl, hang on. It's not localhost. It is, well, okay, so I would have to actually go and get the Docker nodes. Here, this falls apart because we didn't port forward those. Hang on, I got it. There's got to be a way I can do this. kubectl get nodes -o wide shows me 172.19.02. Can I ping that? Oops. Oh, I can. Okay, great. 172.19 kubectl get. Okay, so you're following along. What you want to type is kubectl get nodes -o wide, and that's going to show you the address of your K3D node. In my case, it's 172.19.0.2. You're going to run kubectl get service, and you're going to see those high ports. And now if you were to run curl, whatever your address is, colon, one of those ports, well, that was the staging environment. And we get hello from staging. And if we were to run it against the other one, we will get hello from production. So those are 2 node port services. And now imagine that we had an external load balancer, an F5 big IP or a NetScaler or an A10 or a HA proxy thing or whatever. We would terminate our domain on there, example.com, terminates on an address on the load balancer, and then the load balancer routes that traffic to these ports on the cluster according to whether it's production or staging. So these are layer 4 load balancers. But if you're in a cloud provider environment, they're a one-to-one relationship between an application and a service. If you have 1,000 websites running on your cluster, you don't need 1,000 load balancers that cost $20 a month. You need one, and you need an ingress. So understanding what services are. An ingress is an API definition of how to route HTTP traffic from the outside to a service. The functionality is delivered by a thing called an ingress controller. An ingress controller is a software load balancer like Nginx, HA proxy, Traffic. It could be an API gateway like Kong or Glue. It could be Istio, service mesh stuff. There's lots of things that provide ingress functionality. By default, you'll usually end up with either the Nginx ingress controller on most Kubernetes clusters, or if you're using K3S like we are today, it's going to be Traffic. But you don't actually care today, you just care about what an ingress is. An ingress sits in front of a cluster IP service, and it receives traffic and follows a configuration of host header and path to route it to a service. It's a layer 7 load balancer. It's an intelligent load balancer because it's able to make decisions. But because it's an HTTP load balancer, it can only work with HTTP traffic. Most ingress controllers will also let you punch straight TCP or UDP ports through. Technically, that's not an ingress because it's not part of the ingress API specification, but I still think of them as ingresses because I'm not a stickler for rules. back over here. In the overlay directory, there's also an ingress directory. Let's go into the single ingress, and there is a customization.yaml file in there. This says that we're going to create a dev environment. So environment is dev. It's going to use the same base directory that we were working with before, but it's going to add a local manifest for an ingress that I'll show you in a second. And it's going to patch the service by changing it from a node port service to a cluster IP service. The ingress, same thing you've seen before: API version, kind, metadata, and spec. API version, that's where it is. Actually, in Kubernetes 1.19, it's gone to V1, apps V1. So I don't even know if this will work. It's an ingress. It's got some metadata. Here you see annotations, which we don't talk about in today's class, but it's this, whatever, it's there. Don't be confused. But this part, host. If we receive traffic for a specific host on a specific path, send it to this service on that port. And that's all it is. You can have different paths going to different services, meaning they're going to different groups of pods. So you can break your application out into microservices and send /store over here and /profile over there and /products over there. It's like the Wizard of Oz. First they took my store and they threw it over there. How many of you have seen Wizard of Oz, the original one? Christ, I feel old. So, ingress. But we need to change this because of where we're operating. So up here, you have a thing that says URL. Triple click that and copy it. And then down here under ingress, change host to that URL. If you don't do that, the ingress controller won't know to answer your request for what we're about to do in a second, which hopefully won't break. Save and exit out of that, and then do kubectl apply -k dot for the current working directory. This, by now you know how to do this. kubectl get deploy. What do we got? We got a dev environment. kubectl get pods. Oh, we see we've got a dev nginx pod running. kubectl get service, and you'll see that we now have a cluster IP service running. Notice there's no high port over there on the right. If we say kubectl get ingress, you see that there is an ingress that's listening on a port. If you open up, hopefully this works, if you open up a new tab and you paste that URL, please, oh, awesomeness. That is our dev environment. I'm so glad that worked. So what do we have here? We have, in a single node Kubernetes cluster, we have 3 applications running. We have a dev environment attached to an ingress. We have a staging environment and a production environment attached to node ports because they would be theoretically served by an external load balancer in our silly little example. That's it. That's the basics of Kubernetes in way more time than I expected that it would take. But let's just do a quick recap. What do we have? Where's my slide? Pods. Smallest unit of thing that can be deployed in a Kubernetes cluster. Consists of 1 or more containers that share network space, storage, and some other stuff. They can talk to each other on localhost. They're buds. Replica set manages pods, but you don't really care. Deployments create replica sets that you don't care about, which then manage pods. So you can just think deployments create pods and you'll be totally fine. Config maps allow you to override data inside of a container. We're using it today to override the default index.html file in the nginx container with the little widgets that you saw there. A service exposes a pod, either in the cluster, on a high port, or potentially with a cloud load balancer if you feel like wasting money. An ingress is a layer 7 load balancer that runs directly on the cluster. If you use an ingress, you still need one external load balancer, but now it can be a layer 4 load balancer. So you would still land your traffic there, and then it would send it to all of the Kubernetes nodes inside. It would just send it through on port 80 or port 443. So you do it at layer 4, you just route the TCP traffic through, you don't look at it, you don't terminate SSL, you just, traffic comes in, traffic goes out, and you're good to go. The reason you need to do that is because you have multiple nodes in your cluster and you can't send all of your web traffic to one of them, because if that one goes away, well, then you're done. You also can't do round robin DNS, because if one of them goes away, then still a portion of your traffic fails. So you still need an external load balancer, but now you need one instead of one for every single service. I have no doubt that there are going to be like 8,000 questions over here. Oh, there totally are. Okay, let's jump through it. Okay, Shivash wants to know, how do you configure load balancers in a virtual machine? That's not a today question, I'm sorry. Paul wants to know, what is ext host, the host machine or the guest machine on which the Docker containers are running on? We're going to get to that in just a second, Paul, when we install Rancher. Okay, so Shivash just wants to know, is it possible to configure a load balancer in a virtual machine? Yes, MetalLB, kubevip, if you're in an on-prem environment. Beyond that, it's a more complicated question. I'm happy to talk to you about it, just not in today's class. Join the Rancher user Slack. Paul's still saying hostname being macOS and guest machine being Ubuntu. Yeah, I think I already. Ian says hello. It's so great to have you here. Hey, AJ says muchas gracias. Yeah, de nada. All right. So Paul, I know you're asking this question about Ubuntu and macOS and virtual machine and stuff. I'm probably not going to be able to answer it here just because I don't understand what you're asking. But again, join the Rancher user Slack. I'm Adrian. Find me there. We can talk. I can help you. I run Vagrant. I use a Mac. So we'll get you hooked up. AJ says, hey, now that we understand the basics of Kubernetes, which training must we undergo next to learn stuff about Rancher? You just need to sit with me for another 25 minutes. How's that? Unfortunately, we're probably going to go long. I can't believe I extended the class by half an hour and we're still going to go long. That's just the way it is. The Rancher portion of this, from a slides perspective, is pretty funny. It says, Rancher. Now, here, once again, I have deviated from my normal routine. Normally, at this point, I would install Rancher and I would show it to you. Today, you're going to install Rancher yourself, hopefully. So what I need you to do is, in that labs document that Paul is already way ahead of us on, there is, well, there's instructions. First of all, click Add New Instance, and you're going to get a new instance. Follow the copy and paste of the same commands to install the other things. So we're just going to paste that, and it's going to install curl, which, K3D, customize, and Helm. Okay. We are now going to launch another K3D cluster. And I'm going to call this one R. You can call it, well, we'll call it Rancher. Now remember, you're doing this on the new node. You're not doing this on the same node. Ordinarily, in a Rancher environment, you would have a Rancher server Kubernetes cluster over here and all of your downstream clusters somewhere else. You don't run production workloads, at least today, you don't run production workloads on the same cluster where you've installed Rancher. In like 3 weeks, we're coming out with Rancher 2.5, and that's going to change, but I can only show you what's production today. So this is how we do it today. Whoops, I totally didn't mean to press enter there. I will delete that cluster because I forgot to do the port forwarding. Okay, there's nothing there. So K3D cluster, create Rancher, and then we need to port forward 80, 443, and 6443. Dun, 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 dun. See how when you have a node that doesn't have the no, disk space, rah, this actually works really well. What we're doing is we just created a new K3S cluster. No big deal here. Now we're going to use a thing called Helm, which is the package manager for Kubernetes, to install two things. One is a tool called Cert Manager, and the other is a tool called Rancher. First, we need to add the repositories. So we're down in the document, we're down in launch the Rancher cluster. These are add the Helm repos. So I've added the JetStack repo and the Rancher repo, and then I run Helm repo update and it pulls down the information. Next, we need to install Cert Manager. So to do that, we need to first create a namespace for Cert Manager. Namespaces are logical groupings of resources in Kubernetes that are separated from other things, so you can have stuff with the same name. So a general good practice is you separate out your applications by namespace, because namespaces are the boundary at which role-based access control permissions are applied. We don't get into namespaces in this class, and in fact, I can't even really get into the details of what we're installing here because it just takes time. But you do know that you can watch the rollout, and we just have to pass it the namespace that we care about. So kubectl rollout status deployment called cert manager in the cert manager namespace, and it's already done. Love it. Now, up here, you have this URL value again. Copy that and export that as a variable called ext host. You don't actually have to, but this is just a little bit easier. Now that you have that, you can create the cattle system namespace, and then you can install Rancher with Helm, install Rancher, the Helm chart that we care about, which is Rancher stable / Rancher. We're going to put it in the cattle system namespace, and we're going to set the host name to this host name here. This is actually, that's a really important step. Now, on your first cluster, back over here, I want you to edit etc hosts. At the bottom of that file, you're going to put the host name of the other server, the Rancher server, which you see over here for me is 192.168.0.12, and then the value is what you had in the URL field of the other node. The reason we need to do this is because that URL points to an external IP address. And what we want is we want our downstream cluster, we want our two clusters to be able to talk to each other without having to go up and back in, because that's called hairpin. And from a networking perspective, that's really expensive and usually doesn't work. So what we're doing is we're making sure that we, sitting here at our computers, when we go to that URL, we will go to the external IP. But when our first cluster tries to go to that URL, it's just going to go directly to that other host that's sitting right alongside of it. So what we did, we put node 2's public address in etc hosts on node 1 with the IP of node 2 over here. Hopefully you all got that. Now, back on node 2, we say kubectl rollout status deploy Rancher in the cattle system namespace. It's been successfully rolled out. So we can say kubectl get pods in the cattle system namespace. And you see we have our Rancher pods are up, they're running. So now the super cool part, open a new tab and go to the external address of your Rancher node. You're going to get an alert that there's a self-signed certificate. That's fine. Accept it. And you will now be taken to, oh, my little heart is pounding. You will be taken to, I live in South America. It's really far away from everything. You'll be taken to an installation of Rancher that you just ran. You just installed. Good job. First, set a password. You're going to delete this cluster and when you're done with this class anyway, so set it to whatever you want. Click the little checkbox and say continue. It's going to ask you for the Rancher server URL. Now this is pre-populated with the value from the location field up in the top of your browser, and in our case, that's fine. What this is, and this is why we had to do the Etsy hosts thing a second ago. When Rancher creates or manages a downstream cluster, it installs an agent there, and that agent reaches back to the Rancher server on this URL, and it opens a WebSocket connection, that's a long-lived connection that it uses to receive instructions from the Rancher server. So this address is important. Don't use an IP address here. Otherwise, when that IP changes, well, you're done. Use a DNS name, and it's a DNS name that has to be accessible from the downstream clusters. We will save that. We will say yes. This will clear in just a moment because it's waiting for that URL that we just set. Okay. What you've just done is you've created what's called a Rancher server cluster. That's a big deal. This is a Kubernetes cluster dedicated to running Rancher. In a real world, you would make this an HA cluster with more than one node and fault tolerant with backups and stuff. But for today, we don't care about any of those things. Click Add Cluster up here in the top right. There are many ways that you can get Kubernetes connected to Rancher. Down here at the bottom, you can tell Rancher some credentials, and then it will go out and actually launch a hosted Kubernetes cluster in EKS, AKS, or GKE. Shiva says he still hasn't gotten a new instance from labs. Okay, well, you'll have to follow along later. I'm sorry that that environment is having issues. I will send an email out to them, and I'll probably call it out on the show tomorrow because, well, yeah, because that's what I do. All right, so you can spin up a cluster here. You can also have it launch infrastructure. So rather than launching a hosted Kubernetes cluster, you can give it your credentials. It'll go out to the cloud provider, launch instances, install Docker, install RKE, which is one of our Kubernetes distributions, and then wire that back into the Rancher server. In both of these cases, Rancher does full lifecycle management of those nodes. So that means that you can create more nodes, you can delete nodes. If you delete them here, they get deleted in the cloud provider. So everything is managed directly from in here. If you do your provisioning via any other means, Ansible, Puppet, Chef, Cloud Init, CloudFormation, Terraform, shell scripts, whatever, you just need to install a supported version of Docker. And from this option, Rancher will give you a Docker run command that you put at the end of your provisioner. So when you provision nodes, they automatically join a cluster. For everything else, every other Kubernetes option, if you have Kubernetes clusters already deployed out there in the wild, you can import them into Rancher and it will take over management of them. In that case, you don't get full lifecycle management because Rancher doesn't know how you launched them, but you get all of the Kubernetes management. Let's just create a cluster called demo. And we are now given two options of how to do kubectl. One is when your Rancher server has a real certificate. That's the first option, this one here. kubectl will not talk to an endpoint that uses a self-signed certificate. Ours today is using a self-signed certificate, so we're going to use the second option. You can just click this copy button over here and come back over to your first node and run that. Boom! It just reached out, got a whole bunch of stuff back from the Rancher server. And if we come back over to our Rancher tab and say done, you'll see the demo cluster, or whatever you called yours, is now coming to life. The cluster will install some stuff. You see it's waiting for the API to be available, and in another few seconds, that's going to be green. While we're waiting for that, let's talk about what you have at the global level of a Rancher installation. Rancher will work with other providers besides the ones that you saw in the add cluster screen. For example, there's other, I picked catalogs. If we go to drivers, for cluster drivers, there's a bunch that it ships with that are just disabled. Same thing for node drivers. You can activate these and they become available elsewhere. You can also add node drivers and cluster drivers. These are based off of Docker machine, and our documentation tells you how to create those, or if you find one for, I don't know, something. Packet's already in here, but yeah, if you find something for whoever your provider is, Joyent or whatever, then you can just add those here. If you're running Rancher in production, go to the authentication tab and wire this up with some third-party external identity management system. Once you do that, it will bring in all of those users and groups and make them available for you to assign them to RBAC permissions for all downstream clusters. At the very beginning of the class, I talked about doing this stuff at a global level because it allows you to do it in one place. Imagine you're in an IT ops department of a large company that has thousands of developers across hundreds of teams and has potentially thousands of Kubernetes clusters. A team might be responsible for several different applications on multiple clusters. Those clusters could be in Google, Amazon, under your desk, in your mom's house. They're all over the place. Somebody joins the organization. You get to block out 4 days of your time to go through and create credentials and all of the whatevers and add them to the clusters. And what did I say? You're still going to get it wrong because you're a human being, and that's just what we do. With Rancher, all you do is you just put them in the right group in Active Directory or whatever, and they instantly get access to all of their clusters. And even better, if somebody leaves the organization, you don't have to worry about what did they have access to. You just disable their account in Active Directory, they lose access to everything. Rancher becomes an authentication proxy. So inside of each cluster, you'll see in a moment, there's a kubeconfig file for each user to access that cluster through Rancher. And that's how people will access their clusters. You don't need to create credentials for them in Amazon or Google or Azure or anywhere else. You just use the resources you already have, find Rancher to it, assign them to clusters, go get some coffee. If you don't have a third-party solution, you can still create users and groups directly here, and that's fine. By now, our cluster is up. So it shows up over here. Here's our demo cluster, and it just went unavailable. Why did you do that? That wasn't nice. It timed out. That was supposed to be fixed by the Etsy hosts thing that we did. Well, that's no good. It's going to make it really hard for me to show you the rest of this. This is 162. It's a horrible, horrible name. 7,000 something or other. 7,000 something or other. Yeah, that totally should have worked. Oh, there we go. It's back. We're going to blame Docker for that. Okay. Up here, we have two projects. We briefly talked about namespaces. The problem with namespaces is that you can have lots of them, and if you have somebody who needs access to lots of them, you're back in the business of putting things in lots of places, and you're going to screw it up. Rancher has a thing called a project, which becomes the place where you assign role-based access control. A project collects namespaces, and whatever change you make to the project is automatically assigned to all of the namespaces underneath it. The system project contains system-level stuff. Okay, so this, I didn't get this far in my testing before class. Will this work? Huh. All right, so well, that didn't work. So instead, let's just go to the local cluster because it's still a Kubernetes cluster, and I can still show you. I can still show you stuff directly on it. unless the node I was on just crashed. All right, even though I told you you're not supposed to use the local cluster, today we're going to use the local cluster. So I went into the local cluster, which is where Rancher is running, and I went into the default project. And here you have the ability to do stuff on Rancher. Consider everything that we already did in today's class, all of the manifests and the everything. Let's just duplicate those things in Rancher, and you'll see how much faster it is. I'm here in the workloads screen, and I'm on the workloads tab. I'm going to click deploy. So I'm taken to this really nice form. Create a cluster called demo. I want a scalable deployment of, let's say, 3 pods. And I want to run Monakas/rancher-demo. We only have one namespace, that's fine. I know that this application listens on port 8080, and I want that to be a cluster IP. Cluster IP service only exists inside of the cluster. Twirl down the environment variables section and add a variable in all caps called cow color and set that to yellow. In here, there's all sorts of other things that you could do that we didn't even get to. You can set up health checking, you can set up node scheduling, you can attach persistent storage. There's an advanced options thing down here in the bottom right. If you click that open, you can override the command, you can set security policies, you can do all sorts of crazy stuff. We're just going to click launch. This is now going to go out and create some pods, just like we asked it to do. It created the service for us. That's pretty cool. So let's just real quick come over here and click on the load balancing tab and say that we want to add an ingress. This is going to be, call this demo, and leave automatically generate a host name checked, and hopefully that will work. The path is going to be / and you can just choose the demo workload. If we had TLS certificates, we could add them here, but we don't. Oh, we need to route that to port. We're going to go to port 8080. We'll say save, and that totally failed. Okay, because it's running inside a Docker, so that's not going to work. Delete that. Let's do this again. Demo, this time specify a host name and use the same host name that you have up in the top location bar, the host name of your Rancher server, because that's, if you're on the Rancher server, use that. If for you it did work on the other server, the other node, then you can use it instead. So just use whatever you're actually on. We're going to send / to demo. We're going to send it on 8080. And we'll say save. That's also not going to work because we're on the Rancher server. Crap. There's a thing called the demon of demonstration, which occasionally rears his ugly head. Okay, so we just deleted, come on, delete. Oh, I just totally broke. I just overlaid, yeah. I just overlaid an ingress on top of the Rancher server ingress and totally broke it. Hooray! That's a ugly mess. Let's take a moment to troubleshoot that in the last couple of minutes that we have of class. I'm on my Rancher server over here. Okay, great. So I'm in the default namespace, and you can see the demo pods are running. If I say get ingress, here's the ingress that we just created that is clobbering the other ingress for the Rancher server itself. So kubectl delete ingress demo, just deleted that. The other ingress is still out there, the actual Rancher server ingress, that's important. And now if we come back out here, this should work again. Hey, look at that. Whoops. Come on. Kubernetes troubleshooting, right? We just totally broke something, and then we went in with the command line with the skills that we learned in the beginning part of class, and we fixed it. That's cool. I really wish that I could get onto that cluster. I have to figure out why that doesn't work in the lab environment. Okay, very quickly then, let's just recap and talk about some of the other advanced functionality that Rancher has. Because right now, all I've shown you is how to do stuff with Kubernetes. And I know we're at the top of the hour, and so, but I'm just going to run through stuff. There are advanced things. Rancher is not just a Kubernetes management platform for doing stuff you could otherwise do with kube control. You've got monitoring, you've got pipeline system. If you don't have a CI/CD system, you can just point it at repositories and have it start building apps and deploying them for you. You've got catalogs, so you can deploy applications with Helm. You have horizontal pod auto scaling, where it can dynamically scale pods up and down according to the level of traffic that's on them. You have Istio. It'll deploy and manage Istio for you. You can manage your config maps and your secrets. Secrets are like config maps, but they hold secret data like API keys and passwords and stuff like that. Otherwise, they work exactly the same as config maps, allowing you to mount configuration data into containers. The apps thing, though, is the coolest part. Rancher ships with a curated list of applications, but it also works with any Helm repository anywhere. Imagine that I'm a developer and I'm building an app and I need my app to talk to Hadoop. I don't know anything about Kubernetes. I don't know how to deploy Hadoop with containers. I don't know how to deploy Hadoop in Kubernetes. And more importantly, I don't actually care because that's not my job. My job is to build an application and I just need a Hadoop cluster that I can talk to. If my company's using Rancher, I can come in here, I can click on Hadoop, and I can just fill out this form, which has some sane defaults in it. So if I know enough about Hadoop, I can be like, oh, we don't need persistent storage, don't expose the Yarn UI, or whatever. Configure all of these things, and these are dynamically converted into manifests with variable substitution. And when I click launch, I can't do it because we don't have very much capacity on these nodes, but in a decent sized Kubernetes cluster, it'll hand me back a 5-node Hadoop cluster with full fault tolerance in about 7 minutes. And I can just start coding against it with my application. And when I'm done, I can delete it. That's the real power of what Rancher brings. Rancher makes it easier for you to get from here to where you want to be, which is using Kubernetes without having to worry about all that stuff in between that a lot of people just don't need to know, want to know, care about. And Rancher also makes it easy for you to get up and running with doing stuff in Kubernetes before you know everything about Kubernetes. You can get started. If you know how to deploy a container, well then the information in the form makes sense to you. I talked about how Rancher gives you it acts as an authentication proxy. That happens up here with these two buttons in the top right at the cluster overview screen. You either get a kubectl shell locally here for one-off commands and stuff, or you can say, give me my kubeconfig file, and we can take that, copy it locally, and then use that in our local command line on our local machines to actually talk to the clusters through Rancher. This is generated for every cluster for every user. So the user would log into Rancher with their account and they would get their specific kubeconfig. And that's all that we have time for today. I apologize for what didn't work in the labs environment, but honestly, compared to the way the class normally goes, where people just kind of get to watch me do stuff, this was a huge, huge success. I'll figure out how to make it work better. And if you come join me in not 2 weeks, but 4 weeks, uh, it'll be better. So let me check issues here, not issues, let me check questions. Are there any issues running the Rancher management server on multi-homed servers? Interesting. Multi-homed server would be a server with multiple addresses. No, not that I'm aware of, although I think you can tell it what address to bind to. Since it's a Helm chart, you can go and you can actually look for Helm chart options for Kubernetes installations. There's probably something in there about bind address. Nope, there's not. Well, at least not called bind. So look through there. If it's not in there, then it's just not an issue. It'll just, computers tend to be pretty good about responding to requests from the same address on which they received them. It's a good question. Eugene says, thank you, awesome class. Ah, you're welcome. His computer crashed in the most interesting part. It's okay. We'll be back here in 2 weeks and we'll do it all again. 4 weeks. Don High will be here. He'll still do a class in 2 weeks if you want to come back. It's not going to be this class. It's going to be his class. So it'll be different. But if you want to come back and do more of this craziness, if you like hanging out with me, then yeah, 4 weeks from now. So let's wrap it up. Somebody asked, where do I learn more about Rancher? There's also the Rancher Academy, which I built earlier this year and is the place to go to learn about Rancher. It's current through Rancher 2.3. We're about to release 2.5. There's going to be an overhaul of it, but it is still extremely valuable for how to deploy Rancher, well, deploy Kubernetes, deploy Rancher, use Rancher to deploy and manage Kubernetes clusters. If you spend 3 to 5 hours a week with it, it'll take you about 5 weeks to finish, but you can also just burn through the whole thing all at once if you're crazy. At the end, you will get a certificate of completion that indicates that we have blessed you. There's a test. It's not like the CKA. It's you just do it yourself. But if you pass, then you get a certificate that says that we bless you to go forth and administer Rancher in production, and that's extremely valuable. We're working on advanced level content, but as you know, there's a lot of stuff going on right now between Rancher and SUSE, so some of that's up in the air. Just know that the Academy is a big part of what we believe in. When it launched, there were 1,000 signups on the first day. It's been around since May 15th. We have nearly 10,000 people registered, and we've issued over 1,200 certificates. It's a good thing. It's also totally free. It's at academy.rancher.com, scrolling across the bottom of the screen there. Remember that you can join the Rancher users Slack. You can get an invitation at slack.rancher.io, and then just come and hang out. My name is Adrian Goins. I am the Director of Community and Evangelism at Rancher. My job is to make sure that you, as members of the community, use Rancher, understand it, make it work for you. There's a fine line between how much support I'm allowed to provide, but ultimately I want to, if I can't answer your question directly, I want to point you at where you can get more information and encourage you to ask questions of the community. Our community is amazing. All of them want other people to be successful with Rancher. I told you at the beginning, none of that contact information for me was relevant at the time, but I hope that now it is. I hope that I've been able to demonstrate to you that I care about your experience and about teaching you how to do these things. So I invite you to connect with me through any of those means. Remember, you'll get a copy of the slides afterward. And then, well, there's a couple of other things. First of all, here's what the Rancher Academy looks like. There's also the Rancher YouTube channel where we have thousands and thousands of hours of content. There's trainings, there's masterclasses, there's meetups, there's tons of stuff there. And then I myself have a YouTube channel where I create content about Rancher, but also about Kubernetes and about whatever else. And I've been doing a daily live stream. It's at 7:30 in the morning Eastern every day. It's called Coffee and Cloud Native, where I spend 30 minutes going through what has been new and interesting and new tools and news and announcements for this universe in the last 24 to 72 hours. That's been going on for 9 weeks now. I'm about to actually take 2 weeks off. The last show before the break will be tomorrow. But if you join tomorrow, this is actually really cool for you. Join tomorrow. So you can go to adrian.goins.tv. You see it there. That'll take you directly to my channel. Tomorrow I am giving away a copy of Brett Fisher's Kubernetes Mastery class. This is a class on Udemy on Kubernetes Mastery. I give away one of these every week. When we reach 50 people in the stream, somebody who's in the live chat is randomly chosen to win. But tomorrow I'm giving away 2 of them. One of them is because this week I reached 2,000 subscribers on my channel, and I want to say thank you all for coming and listening to me go on and on and on. So I'm giving away one for that, and then I'll also be giving away another one. If we can get 50 people in the stream again, somebody in the chat will win. We've hit it easily the last 2 weeks, so I invite you to come tomorrow, 7:30 a.m. Eastern, and hang out with us. So that's it. What are we at? We're 7 minutes over the crazy. Wow. Thank you so much for joining me today. I'm going to do one last check of the questions panel. Okay, no questions. A lot of you are saying thank you. No, thank you. Like I would come here and if I didn't have you guys to talk to, this would be a really stupid class. So thank you for coming. Thank you for being interested. Thank you for investing in your future because Kubernetes is hands down the most important thing you can learn right now. Have a great rest of your day. I'll let you go. Thanks for staying late. Take care.